Yes.
Good morning.
Morning.
How are you?
Doing well. How are you?
Good.
Can't believe it's
Well,
last day of class.
I know. This thing is just zipped by. Well, so today I don't really have a whole lot on the schedule. Just kind of wrap things up and let you know how the next week is going to go, and then we'll see where it goes from there. So let's quickly run down what's left to do. So we've actually got one more week of the semester, that's next week, and during that week I'll be meeting with you for about 5 minutes in order to go over all of the programs you've written during the semester and then reach a consensus about what grade you're going to get. So before that meeting, there's a couple things you need to do. One is go all the way to the bottom of our Canvas website, and there's some instructions on how to prepare for your conference with me, and then also how to actually find a time slot, and then finally there is a reflection survey for you to fill out. So when you read the instructions for how to sign up for a conference, make sure that you have, of course, gone through all of your assignments and make sure you've turned them in. I'm going to catch up this weekend and get everything like recorded as far as being complete or incomplete, so we've got a fresh slate to go on next week. And then you need to, what am I thinking about here? You need to go through Confer Zoom and sign up for a time slot. And I've had some reports from some students that it's not working, that when you go to look at the appointments that are available, there should be a drop-down menu that lists all the teachers you can sign up for time slots with. And my name is not appearing there for some people. And I have to put in a help request to find out what's going on, because I've done all the debugging I can on my end and had the students do some debugging as well, and it's not appearing for them. But other students are able to sign up for time slots, and so I'm not quite sure what the difference is. And the third thing is to fill out that reflection survey. It'll take about 30 minutes to fill out. You're going to go through your assignments and just see which ones you've completed, which ones you haven't completed yet, and then answer some questions about how did you feel about the assignments you did this semester? Did you learn something? Were you able to apply it outside of the classroom? Were you able to find some way to use this information outside of just this course? And then finally, what grade do you think you should receive for this course? And I've given you a rubric for kind of establishing what's the criteria for an A, a B, a C, and so forth. And for getting an A, it doesn't have to be that you got all the assignments done and you got perfect on all of them. It's just going to be, did you get the vast majority of them done? So it's okay if you maybe missed one assignment. That's probably okay, but you need to make up for it probably in other places, like, were you able to apply the information somewhere else, sort of thing. So I've given you some criteria for thinking about what grade you got, and then I will also go through your survey and I'll write down some notes about what grade that I think you've received. And then if we agree, then that's easy, right? If we agree on what grade you should get, then that's probably the grade you'll get. But if we don't agree, then we'll have to reach a consensus and figure out what grade you actually got. But chances are we're going to be pretty close on the grade. So there's nothing you have to study for. There's nothing you really have to prepare for other than filling out that survey. It's really fast, no more than about 5 minutes or so. And it's not going to be, I'm not going to be quizzing you or anything like that. It's just going to be you and I having a little short conversation. It's really not that much different than if you were in a work situation and you had your annual or semi-annual review, where you just sit down with your manager or supervisor and he or she just goes over, how you're doing. And so it should really kind of be no surprise when you walk into this about what I'm going to say and how I'm going to be interacting with you. So are there any questions about that process? If you possibly can, sign up for a time slot earlier in the week. I've noticed over the semesters that the students tend to put it off until later in the week, and then I'm just trying to cram in dozens of appointments during like the Thursday and Friday. So if you possibly can, do it on Monday or Tuesday, get it out of the way. That way also, if there's some issues that came up, like maybe there was an assignment that you had been marked incomplete, but maybe if you put another hour into it, you could complete it, then you could go ahead and do that, and then we can come back and revisit that, and then maybe change your grade as a result of that. So it'd be better if you got the appointment done earlier in the week rather than later in the week. So any questions about that process? No? Sounds good. So the other thing I wanted to bring up was we got summer break coming up. If you're not taking any computer science classes over the summer break, then what invariably happens is if you get out of practice of doing some programming, by the time you come back to classes in the fall, some of the knowledge has kind of slipped away. So what are some things that you could do over the summer to kind of keep the practice going? So let me show you some websites that have worked well for me. Hold on a sec here. All right. Let me turn this off. There we go. So one of them is called Project Euler. And here's the web address, projecteuler.net. And this is probably one of the older ones that's been around. It's been around for a long time. You can click on Archives, and what it gives you is there are several hundred little tiny computer programs to write. And most of the programs are fairly short, but again, the whole point here is just to develop a solution to a problem and then just get practice writing a program. I think a big part of doing the practice is simply just starting over again with a blank program and then trying to figure out what's the next step I need to do to help solve this problem. So if you sign up for an account on here, then you'll get access to the ability to submit your solutions. But you can look at the problems even without signing up for an account. So maybe you click on the first one. And it says here, if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. What is the sum of all the multiples of 3 or 5 that are below 1,000? So you write a program to solve that problem. And again, if you register for an account, there'll be a box right here for you to copy and paste the answer that you get. It'll just be a number. The computer, the website will check your solution, and if you get it right, it will then give you access to look at solutions that other people have turned in. And by solutions, I mean the programs that they wrote. And it's really great because you can see solutions written in C, Python, Perl, Visual Basic, Fortran, Prolog, Lisp, Scheme, like probably dozens of programming languages, and see how that particular problem was solved in that language. The problems more or less increase in difficulty as you go down the list. And I say more or less because it's not expected that you have to do these in order. You can just kind of scroll through them, look for a problem that looks good to you, and then tackle it. Somebody here on the chat said that their computer doesn't seem to be able to cope with number 3. What's the largest prime factor of this number? Now this number is, I believe it's bigger than an integer will hold. So you'll have to go for probably a long, which is a 64-bit number rather than a 32-bit integer. And then to find prime factors, with the large find prime factors, all you have to do really is just try all the possibilities until you stumble across it. Now, one of the things I've noticed about some of these Project Euler problems is there's often kind of the brute force way to solve it, and then there might be a better way to solve it. So just looking at the size of this number, I'm already thinking, boy, it's going to take a long time for this thing to run through all the possibilities and find the factors. maybe there's a better way. Maybe there's a better way to find the answer for this. So just go through the problems. Find one that looks like something you could tackle, and go ahead and do it. Work out the first 10 digits of the sum of the following 150-digit numbers. Boy, wow. The first 10 digits, so that would be like these. So you'd have to somehow like add all these up. Now clearly you're not going to be able to do this even with 64-bit integers. These are much bigger than that. So, you know, you're going to maybe have to look into a library for doing arbitrary precision integer arithmetic. Or maybe there's some other way you could do this. Like maybe you could just basically write your own. Each one of these numbers is read into an array of integers, and then you just start doing it the way that you probably learned in grade school, right? Add up all the ones columns, and then calculate any carry and bring that over to the next column and add all those up and just kind of roll through all the numbers until you end up with the sum. So that's Project Euler. Another one is normally active during the holiday season. This one's called the Advent of Code. So we're looking at the one from last year, 2021. But you can do this anytime you want. It's just that they've got like a competition going, and then it's active during the 25 days of Christmas. So the way this one works is there's actually 50 problems to solve. There's 2 per day. You click on day number 1, and you've got a problem description to write along with some sample inputs. And then again, if you register for an account, there will be a box for you to type in your answer. And then it checks your answer, and if it got it correct, then you're given access to the next problem for that day. And then that just keeps going. And this one, you are kind of expected to work it in order because the problems don't become available to you until you've solved the previous one.
I've done some on that one. That's a fantastic site.
Yeah. And I guess one of the cool things about it that I just realized last year is everybody who plays gets a different input. So you can't just find someone else's answer and just plug it in. It's not going to work, right? You got to write your own because you'll get a different set of inputs than everyone else. How far did you get on this one?
I think I got, I keep wanting to go back and finish it up, but I think I got through day 18 on last year's.
Wow.
And I did a little bit of, no, I'm sorry. I'm thinking it wouldn't have been last year's. It would have been 2020's. I went through day 18.
Still, that's pretty impressive.
Just a few from the time before, and it's just limited by free time. Yeah.
Do they get more difficult as you go up in the days?
Oh, yeah. They get more difficult. And I mean, what I like about them is they're 2-part challenges where you solve, each day is 2 parts. You solve the first part, and then they change something up. And they say, okay, now that you found the solution, now change some behavior about it or something. There's something new in the input. And then you have to go back and refactor or modify your solution.
That's actually, I think, a big part of the Advent of Code is having to go back. And even later days, like I think I was doing it, I don't remember if it was 2020 or 2019, but over the course of the 25 days, you were basically writing a compiler. You were like having to translate some source code into some fictitious machine code. But you started out with just like a basic operation like add, and you wrote a program to turn that into their little machine code. And you didn't realize until maybe day 5 or day 10 that you were slowly having to write a compiler that accepted more and more instructions. And so now you got to say like, well, I went back and I just kind of like wrote a really simple program to turn this input into this output. And now I got to think about parsing and code generation and structuring the code so it's easier to plug in new instructions. So some of the comments I saw was people had to go back and just basically redo their early programs so that it would make it more modular and able to kind of accommodate the subsequent days. But of course, nobody knew what those problems were going to be like, because they don't open up the problems until that appropriate day of the 25 days of Christmas. So I think that's a really, really neat thing about it. And the person or persons who are responsible for this website just put in an amazing amount of work over the year to come up with these problems. Now, another one is lead code. I'm not too familiar with this site. This was brought up by some of my students. But again, it's kind of like programming competitions along with a lot of tutorials. So you got tutorials on working with arrays and linked lists, binary trees, recursion, machine learning, binary search, and then kind of problems for you to work on, problems that are related to or similar to the kinds of problems you might get on a technical interview. And again, I'm not too familiar with this website, but a lot of people do seem to like the material that's in here. So these are some things that you could do over the break to just kind of keep up the programming creative process, and just keep yourself in good practice, and so that when you come back in the fall, you'll have not lost a whole lot of what you had gained over the semester. What else we got here? We got a question about, it's kind of an odd question. How do you remember math tables up to 20? Well, my third grader is kind of going through that right now. He's trying to memorize his multiplication tables, and it's really just repetition over and over and over again. We've got flashcards, we've got grids, we've got little worksheets for him. There's nothing much more to it than just simply looking at it over and over and over again until you memorize them. And the thing about him is he stubbornly refuses to memorize them. I don't know about your kids, but he's like, I can figure it out. You do like 7 times 9. He just goes like, and he's running through the multiplication in his, or the addition in his head. He's like adding it up, and I'm like, you need to be faster. He's like, but I got the answer, right? And it's like, no, you need to like just memorize it so that it's just 63 comes out, right? Don't think about it. And he's like, but I got it. Like, it's been kind of a struggle with him.
I'm going through that with one of my sons right now.
I mean, he knows the answer. It just takes a while because he's not memorizing it. He's just figuring. I mean, there is certainly something to be said for deriving an answer when you don't have it memorized, right? That's certainly a skill that's important. But at some point, it would help to just memorize those basic facts so that when you get to things like division, the multiplication in reverse is easy to do, right? You do 63 divided by 9. Oh, that's 7, right? Because I don't have to think about it. What's going on with me this summer? So we're going to take about 2.5 months off, and then we'll be back in August, and we'll start the process all over again. Now, next semester will be different. I have not actually stepped foot in my office or onto my campus in over 2 years. That's not true. I've stepped foot on it, but I've not been there for more than 30 minutes total. So it'll be interesting to see what's changed. I hear there's been some construction, and so it'll be a little bit different. Now, I'll be back in the classroom for my discrete structures course. I'll also have a couple of online sections, but my goal is, again, to do live streaming, in part because I think that as education has come out of this pandemic, things have changed permanently. We can no longer just have an on-ground experience that is totally different from an online experience. I think a lot of students now expect things to be blended in some way, like making lecture material available on videos so that they can watch it if they have to miss class. If they're sick for any reason now, even if they're just out sick with a cold, they still want to be able to get access to that instructional material. And so my goal is to like put some cameras in the classroom and record the lectures just like I have been, except I won't have this nice backdrop here. It'll just be the regular classroom. And then for the C class, we're hoping to also maybe do an on-ground class, but we'll see how that goes. And it could also totally change. We're planning on being on ground next semester, but who knows? If there's a resurgence of COVID, we could all just switch back to being online again, and then I'll be back here. So it's all kind of up in the air right now. So what am I doing this summer? So I'm going to probably go through and take some of my videos and kind of edit them down so that I just have the content rather than a lot of the discussion, and then we can come to the classroom and do more of the discussion. Also got some side projects I'm working on. Do you remember earlier, a couple of weeks ago, I showed you the binary data being sent down the serial line? So that was really cool. It's the first time I had done actual packet disassembly. And at the beginning of that demonstration, I said, well, we have these modems, right? And these modems can't be used anymore because, well, hardly anyone's got one of these phone lines that we can plug it into. Everyone's just got their cell phones now. But then I was turned on to this little gizmo here, which you can buy on the used market pretty cheap. And this is a voice over IP box that you can get. These days, if you want to get standard phone service, you might go through a company like Vonage or I don't know what they're called, like Fast Dial or something like that. And basically it uses your internet connection to do standard phone service. So you get a box like this, plug it into your internet using the Ethernet jack right here, and then it's got a couple of just phone jacks that you can plug regular old phones into. And someone said this particular box, the Cisco box, is unique because you can assign a phone number to each one of these jacks, even if you haven't subscribed to their service. Even if you're not subscribed to a voice over IP service, you can just assign your own phone numbers or any phone numbers or any arbitrary phone numbers to these two jacks. And then if you've got two modems, you could then just wire them in and they could call each other. I'm like, well, that's pretty cool. So that's what I'm working on over the summer. And then my goal there would be, if we can actually get the modems talking to each other, we could then look on the oscilloscope and see the actual audio waveforms going down the wire and then be able to decode those and see the high pitch noises and the low pitch noises being used to indicate the ones and zeros. So that's one project I'm working on. What else have I worked on? Oh, actually, this is a project that I have been working on over the past couple of weeks. I was introduced to a fellow who has muscular dystrophy. And there's many varieties of muscular dystrophy, but there's one in particular that causes a person's muscles to basically just atrophy, to just basically become useless. And he's in his 20s now, and he can't walk. He can't even hold himself up. He has to be in a wheelchair. And the only motion he has left is he can move his head, and he can move like the tips of his fingers and the tips of his toes, and that's it. The rest of his body is just completely useless. And so he used to be kind of an avid video gamer back when he had more mobility, but since he's lost all that mobility, he can no longer play video games. All he can really do now is just sit in bed and watch movies. That's his life right now. And so I thought, well, this would be a great opportunity to see if we can have him use his video games again. And Microsoft, he has an Xbox, and Microsoft actually is really great in that they have this device that you can get called the adaptive controller. And it's basically a giant gamepad. It's about a foot wide, or yeah, about this wide, about this tall. It looks like a giant gamepad. But the cool thing about it is it's got all these plugs in the back. And these are not proprietary in any way. They're just standard, audio jack plugs. But if you can connect up some kind of device, like a switch, a button, a joystick to it, then the adaptive controller can turn that into something the Xbox can understand. And so went out and got a whole bunch of buttons and switches. So they look kind of like this, or they're big buttons. So he can use things like his head too. He could lean his head over, and basically if he had the switches on either side of his head, kind of like this right here. Kind of like what you're seeing right here. Right? Basically use his head to be like a switch, and got all these other buttons that we could. And remember, he can't move his hands. He can't physically pick up his arms to hit something. So everything's got to be, basically we'll take his arm and just place it right where it needs to be, and then he can just use his fingertips to touch the buttons. But the joystick was kind of a problem because, again, he can't, you think about a traditional controller, he can't grip the controller. He's got no muscle grip at all. All he can do is just kind of use his thumbs to move the joysticks a bit. And so I saw this in the picture. I went, oh, this is perfect, right? Get one of those nunchucks from a Wii and just plug it right into, and this is the USB port on the side of this for doing the nunchuck. And so I went on Amazon and said, is there a USB nunchuck that's out there? And the answer is no. This product does not exist. A product where you can just take a nunchuck controller and plug it into a USB port. And there must be a reason why they've actually edited this out, because this wire does not actually go like this. There's something else going on. But you can get these nunchucks for the Nintendo Wii, and they're fairly readily available. And so, hold on a sec here. I got it. I got one. So the nunchuck for the Wii has this special proprietary Nintendo connector on it. And so what I did was I said, well, I'm going to use one of those little microcontrollers. They're little tiny computers, about an inch wide and 2 inches long. So here's one. They're about $4. See if I can get it to focus. There we go. And it's got a little microprocessor on it, and then a whole bunch of places where you can attach wires and things like that. Oops. And it has a USB port where it gets its power and you can program it. And so what I did, let's see if I can bring this up for the camera, was I made one. So right here, this is the nunchuck wire coming in, and it's just got a connector on the other end. I got a nunchuck extension cable. Cut it off, attach the wires to some of the connectors on here, and then I wrote a program that would take the nunchuck commands and turn it into USB commands, so gamepad commands.
Can you say again what that board was?
This is this particular one is the Raspberry Pi Pico. You're probably familiar with Raspberry Pi. They developed like little single board computers with Ethernet and USB and video out, but they decided to branch out and enter the microcontroller market. So you can buy these Raspberry Pi Picos for about $4, really cheap. And they can be programmed in C, but I programmed it in Python. The reason I chose Python was very rapid development, and there's libraries available for reading the nunchuck commands, and then there's also libraries available for turning this into a gamepad emulator. And so I've been working on that for the past week or so, and I just got it going this morning completely so that I can do things like plug this in and then plug in a nunchuck, and it will translate the commands. And if I unplug the nunchuck and plug a new one in, it doesn't crash like it was a couple days ago, where it freaks out because I've unplugged the nunchuck. But now I've got it so it can detect the nunchuck's been plugged in and plugged out and unplugged. And so I'm looking forward to maybe this weekend going back to that fellow's house and saying, okay, we've got it all set up. Let's get you playing your video games again. Oh, I'm sorry. I didn't have this set up with this camera here. So all you saw was a little tiny picture. So here's, again, what it looked like. Let's get it to focus. Come on. You can do it. I have to step out of the picture so the camera will focus on it. It has no idea what I'm doing. There we go. All right, so there's a little tiny microcontroller here, and then these holes where I can attach wires to it. And I've got this extra button here for debugging purposes. And then USB port over here, and then this goes to the nunchuck controller on this side. So again, I wrote all that programming in Python. The program itself is not that long, thanks to all these wonderful libraries. Yeah, so it's programmed in Python. Now, of course, Python is not a natively compiled language. It does actually compile a little bit. When you run your program, the Python compiler, if you will, takes over, and it does a quick pass through your program. It does things like, you know, turn numbers into their binary values and establish memory locations for variables and, you know, other little optimization steps. But it still turns it into a bytecode, which is then interpreted by the Python runtime environment. It's really not that much different from Java, in which Java is compiled into a bytecode, and then that bytecode is interpreted by the runtime environment. But Python just does the compilation step really quickly when you run the program. You can actually send a flag into the Python compiler and tell it to save the compiled program. And then it won't have to do the compilation step the next time you run it. And that's more or less what happens with this Raspberry Pi, is when you run the program, it quickly compiles it and then saves the bytecode to a file so that it doesn't have to do that again the next time you run the program. But it's still not going to run as fast as a native program, but for my purposes, it's plenty fast. I mean, the speed of the processor is like 500 megahertz. And so all I have to do is just sample the nunchuck location, the joystick location, about 100 times a second, translate that into the USB commands, and send it on its way. So it's actually a pretty, you know, pretty low speed process, right? We don't need a whole lot of processor speed to do it. What else? So also during that demonstration of the serial commands, I showed you that old Mac, the one that's sitting right, whoops, over my shoulder over here. And I said that on the back of that Mac is a place to plug in a modem, a printer, external storage, and then a keyboard and a mouse, and that's basically it. What those old computers from the late 1980s and early 1990s all lacked was any kind of way to sort of natively get it on the internet. Back then, Ethernet controllers and Ethernet cards were just really expensive, and they weren't very fast. 10 megabits was about all you could get back then, and they cost several $100s. So it just wasn't common. And of course, people weren't using the internet like they do today, so it just wasn't common for computers to have any kind of native way to get on the internet. You could get it as an expansion board. There was actually one slot inside that Mac where you can plug in an Ethernet card, but they were, you know, back then they were extremely rare. People just weren't very popular. And so today they're even rarer. But Apple was one of the first companies, no, I wouldn't say one of the first, but maybe one of the first to bring it to their consumer market, a way to get their computers networked together, so at least you could do things like share files, and you could share a printer. And it was an old communication protocol called AppleTalk. It predated mainstream IP and TCP. One of the cool things about AppleTalk was it was self-organizing. You plugged a device into an AppleTalk network, and then it just learned what address it should be from the other computers. It would kind of like poll around and go like, what address are you? And what address are you? And then it picks one that's not being used. And it's really nice because it means you don't have to set up a DHCP server. You don't have to set up a router. You just simply start plugging the computers together, and then they self-organize into a network, and you can start sharing files, and you can share a printer. And here's what the devices look like. Let me reach back here and get one. So here's one. It's a little tiny box, and it's got this is the Mac serial connector. It's a little round connector with 8 pins on the inside of it. And then this box here, it just has what looks like phone connectors. Actually, they are phone connectors. The cool thing about this was you could plug it into your existing phone network in your house, your existing phone wires in your house. And so if I had a computer here in my office, I would just run a standard phone cable from here to the jack in the wall. And then if my wife also wanted to share files with me or share a printer, then she would do the same thing. She'd plug this into the back of her Mac, plug another wire into the back of the jack in her room or wherever it was, and we could just start sharing files and share printers. It was a really, really easy to use computer network. And kind of like connecting computers to a switch, except that there's no standalone networking device, right? The computers are all daisy chained to each other. So this one goes out, connects to another computer, and then that computer will connect to another one, and that computer will connect to another one, and you make this chain of devices. And then later on, Apple started developing a way to bring TCP/IP, so the IP protocols, to AppleTalk. And it's called IP over AppleTalk, right? Basically, you take an AppleTalk packet, and then you embed into it the IP and TCP packets that we saw, what was it, last week or the week before? But then you do need a piece of hardware that has an Ethernet jack on one end and then one of these things on the other end to translate the packets back and forth, to basically turn an AppleTalk packet, pull out the IP information, stick it into an Ethernet packet, and then send it down the Ethernet cable. And back then, of course, you could get devices like that. They were called AppleTalk IP bridges or AppleTalk Ethernet bridges, and they cost a couple $100. And you can still find them on eBay, used devices. Or you could run some software on a Mac. So if you had a Mac that had an Ethernet port and a serial port, and there was only a couple of generations of Macs that had both, then you could run some software on that Mac, and it could act as the bridge. They would basically take a packet coming in through the AppleTalk connector, like I said, strip off, extract out the IP information, put that into an Ethernet packet, and then send it down the Ethernet cable. And then the reverse would happen. When one came into the Ethernet jack, Ethernet cable, pull out the IP information, put it into an AppleTalk packet, and then send it out the other side. And so that's one of the projects that I've been interested in doing, is actually making one of my own of these things. And again, the process sounds pretty simple. You just have to read in a packet that comes in through the serial line, pull out the information, reconstruct it into an Ethernet packet, and send that back out. So I have the beginnings of it. I have not gotten any further than this, than taking a breadboard and getting some of the parts. So this here is a Ethernet jack that you can get. It's actually got a little tiny processor on it, right here on the bottom of it. And again, these don't cost more than a couple dollars. But the nice thing about having an Ethernet jack with a little processor on it is that we can now we can basically send data to it, and it will construct the packet for us and send it out the jack. And then when data comes in, it will receive the packet, pull off the header information, and then raise a signal on one of these pins, an electrical signal that says, hey, a packet's ready. And then the microcontroller, which is one of these guys, again, this is very similar to that Raspberry Pi Pico that I showed you. It's an ARM chip. It will receive a signal that says, hey, a packet is ready. It'll pull the data off the Ethernet jack and then go to work extracting the IP information out of that packet and then turning it into a AppleTalk packet. And then that's where this chip comes in. This is a serial communications chip. This is the same chip that's inside that Mac over there. And it's responsible for taking the data and then turning it into a serial packet and then sending that packet down this line. So all this microcontroller has to do is pull the packet in, extract the information out, construct a new packet, send it to this guy. This guy will send it down the wire, and then when a packet comes in over the serial line, this controller will take that packet, pull out the pieces, construct an Ethernet packet, send it over to this one. So again, a fairly simple job. And I haven't decided yet whether I'm going to use this, which will be programmed in C, or now that I have some experience using Python on the Raspberry Pi Pico, maybe use this one. I kind of liked doing this one because of the rapid development edit cycle. I could edit the Python code, click on save, and then that code would start running almost immediately on this. Whereas with these, I would have to compile the C code and then upload the code to this, which can take, I mean, it doesn't take very long, 10, 15 seconds, but still, you're waiting, right, for it to start doing its work. And then if something's wrong, then you go back and edit the code and recompile it and upload it to this. Whereas right here, this mounts as a USB drive. And so you edit the code directly on that USB drive. And every time you hit save, it just starts rerunning the code over here. So it's very, very fast. Plus there's lots of libraries available. So I haven't decided which microcontroller I'm going to use, but I have plenty of both. Again, they're very cheap. $4, $4 or $5 for this one. So that's another project that I want to work on. And then of course, if I get that going, then I'm just going to open source it and make it available for anyone to use.
How do you, if you're sorry, if you're interested in a project like that, how do you figure out what like a small talk packet looks like? How do you determine how you have to format the data? Is documentation?
Yep.
Okay.
Oh, can't see this. This is called Inside Apple Talk. And then somewhere in here, here we go. You have a kind of a chart that kind of looks like the one that I was showing you last week, right?
Yeah.
It shows you what all the bytes in the packet mean. So, so we got flags, destination, source, what type of packet is this, and then your data goes right here. So what my program needs to do is strip off this portion of it and then replace that with the Ethernet portion of it and then send it on its way. So that shows you what the framing packet looks like. And then there's other chapters in here that go over like what do the payload packets look like. Yeah, so that's a couple of the projects that I want to work on over the summer. Let me see if I can catch up on some of the chat messages here. Oh, someone said it's kind of like running Ethernet over the main. So you can get these little boxes called Ethernet over power line. And I actually use that in a couple of places in my house where where the Wi-Fi doesn't reach very well. And it's just a little box you can get. It's got an Ethernet jack on it, and it plugs into your electrical outlets. And so you just run Ethernet cables into it, and it sends Ethernet packets over the power lines. It's not super fast, maybe only a couple megabits, but it's enough where the computers that are using it or the printers that are using it can get their data. And it's kind of a cheap way to just extend the Wi-Fi and extend the Ethernet network. And again, it's not super fast, but it's better than running cables along the floor. Who developed TCP/IP? Well, it's not one person, but it was a group of people, and Oh gosh, you got to go way back. I mean, the original internet was called ARPANET, and that was actually run by not only the military, but also a few research institutions, mostly in California. So I think like UC Santa Barbara, UC San Diego, Stanford, Berkeley. They were one of the first institutions to get what we would recognize now as being the internet. And the first packets that were sent across the internet were basically just "Hello World." And there's what's his name? Vincent Cerf, CERF. He was one of the main architects of the early internet. And it kind of stayed as a research institution and network for a very long time, in part because there was this sense that if the internet was developed at public universities and in the government, then it is funded by the public and it is owned by the public. And so none of these institutions can kind of lay claim that they own the internet or they own how the internet works. And so there's a lot of resistance early on to privatizing the internet the way it is now, where you get your internet service from not a public company like the government, but you get it from a private company like a cable provider or a phone provider. And also there was a lot of resistance to using the internet for commercial purposes, like conducting business transactions on it, because again, the sense was this is a public network funded by taxpayer money, and so we own it, we the people own it, and therefore, we need to keep business off of it. There was nothing preventing that from happening, but I think it was just kind of a, not ethically a good idea to run private businesses on a public network. But that all changed in the early to mid 90s when, there were some companies that started providing internet service to their customers. And, it wasn't like a switch was turned on and suddenly there were dozens of internet service providers. It was, or hundreds of them. It just went very, very slowly, where you might got maybe one company was a spin-off from a research university, and they decided, we're going to make email available to our users, which maybe only numbers in the dozens. And from there, it just kind of trickles out where, okay, well, if you're doing it for a dozen people, why don't we do it for our company? Maybe one of the early companies was Texas Instruments or Tektronix. Why don't we make email available to them, because we've been really instrumental in getting the equipment that runs the internet, up and running. And so it just kind of like went from there to where by the mid 90s, you now had private companies offering internet service to their customers. And then you had companies like America Online and CompuServe running their own networks, like the America Online network. But oh, by the way, you can also send internet mail through it. So it's kind of like the internet was a little side service that they provided. To the point where by the late 90s, that became their primary service. So it all just evolved over a decade or so from research universities to private companies the way it is now. Can you create your own protocols? Absolutely. It's actually done quite frequently. The question is, at what level do you want to develop the protocol? Do you want to develop kind of at the what you call the link level protocol, link layer, where you're working on the actual ones and zeros signaling that go down some kind of medium? This happens all the time. Some new medium is developed for sending signals. The most common ones would be phone lines, coaxial cable running from a cable company. They had to develop their own link layer, data link layer protocol, because you've basically only got two wires running to a customer. You've got the central wire, and then you got the jacket that runs around it. And how do you put two-way data down basically one pair of wires? And how do you protect it so that if somebody taps into their coaxial cable, they can't access the data from their neighbors. And then how do you translate that all into the Ethernet packets that we plug our routers into and our other computers into? So that all had to be invented. And then there's fiber optic cable, and there's different kinds of fiber optic cable. There's multi-mode, single mode, there's ones that go long distances, short distances, so those all need their own protocols. There's wireless links, so Wi-Fi is its own protocol. But almost all of these protocols are just framing protocols that allow you to put some other payload into it that contains the IP and the TCP information. Before there was TCP/IP, we talked a little bit about AppleTalk. So Apple had its own. Novell was a company that had its own file sharing protocol. There were many, many others. And it just so happened that TCP/IP and the Ethernet stuff just became mainstream, right? It kind of like won the battles. In part because it wasn't owned by any one manufacturer. It wasn't owned by any one company. AppleTalk was owned only by Apple. And so if Apple decided not to support that, then it just fell by the wayside. Novell also. Novell eventually got bought, and their protocol just went by the wayside. But TCP/IP is not owned by any one company, and so it was kind of destined to survive. So at the higher levels, protocols have to be invented all the time. You've got some new service that you've created, like, I don't know, some game server or something. And so you've got to decide how is data going to be sent and received from the server and the game clients. You know, you could use a nice wrapper like JSON or XML, but that's probably going to be like too wordy, too much excess stuff. You really, for something like games, you're really worried about how can I get my packets to the server as quickly as possible? How can I get the responses back as quickly as possible? And so you're going to probably want to compress the data. You're going to want to remove any redundant information and just get just the essential information over to the other side. And you're going to have to develop a data structure for doing that. And that would essentially be its own protocol. So yeah, new protocols are invented all the time. It just depends on at what level. Low level, hardware layer protocols, or higher level application layer protocols. Please explain Wireshark history. I don't know much about Wireshark, other than it's a way to listen in on packets being sent and received through some kind of medium, whether it be Ethernet or Wi-Fi. For the history for it, I don't know too much about the history. I mean, all I know is that the underlying tools, like the packet capture libraries, have been around for decades. And although tools like Wireshark exist, my own preference is to use something like, what is it called? TCP Watch, I think, is just a command line tool that essentially does the same thing. Oh, TCP dump. Yeah, that's what I was thinking. You're right, right. Wireshark is just a user interface for TCP dump. So, you know, when I'm watching packets, I'm mostly looking to see, are packets being sent between these two computers talk to each other. As far as analyzing the contents of them, I'm not usually myself so much interested in that, but that's what Wireshark is good for, is taking the disparate, possibly out of order packets that are sent between two computers and then rearranging them so that you can actually see the data inside of them. Yeah, you know, here's one thing that there's some YouTube videos on this. You could actually sit down at like a coffee shop and connect to the coffee shop's unprotected Wi-Fi network and basically just look at all the Wi-Fi traffic going through. And back before websites were encrypted by default, you could see things like passwords go by and HTML documents and image documents as they were being sent and received by the various people using the Wi-Fi network at the coffee shop. And so you could literally, like, using something like Wireshark, you could point at the list of computers that are on the network, and you could say, show me all the traffic that this computer is sending and receiving. And then it would show you in a window, like, here are the web pages that they're looking at, and here's the emails that are being sent, and here's the banking information that's being sent. It just scrolls by on the screen. It's really easy to do. And then you can do stuff like you could create your own access point with the same name as the coffee shop's access point, and then just basically act as a middleman. So everyone connects to your access point, and then you just shuttle the information off to the coffee shop's access point, and you just watch all the data going by. Or change it. You could alter the data too. You know, you could do something like every time they load the Google web page, you could put an ad on that web page. Or you could capture usernames and passwords. Oh, what else? Let's see. Back to a Python question. So you can, so the question was, can you compile Python into C? And you can and you can't. See, Python is, well, let me back up a bit. A lot of people say that languages are either compiled or interpreted. Like C is a compiled language and Python's an interpreted language, but that's not actually the correct terminology to use. See, programming languages can't be compiled or interpreted. There's nothing about Python itself that makes it only an interpreted language, and there's nothing about C that makes it only a compiled language. There are C interpreters out there. They're not real common, but there are C interpreters, and there are Python compilers. It's not languages that are compiled or interpreted, it's languages implementations that are compiled or interpreted. So most C language implementations are compiled, and most Python language implementations are interpreted. But there's no strict rule that says they have to be one or the other. Now, there are certainly some aspects of the C language and of the Python language that make it more appropriate for it to either be compiled or interpreted. One of the things about C is that, for the most part, you know, or the compiler knows, all the types of all the variables because the programs require that you pre-declare the types of variables before you use them. So it knows that the variable x is an integer, and it knows the variable a is a string, and it knows the variable p is a pointer because that's the way you declared them. And so as a result of that, it's able to make certain optimizations about and certain assumptions about how the program is going to run. If the program is not a recursive program, and it can very quickly analyze whether the program is recursive or not, if it's not recursive, then it's got a pretty good handle on how big the call stack is going to be. Like you can just look and see, okay, main calls this function, and this function calls this function, and this one calls this one. So I can see the total depth of the call stack is going to be 3. So you can set aside just enough memory to handle that size of a call stack. Python, on the other hand, is a dynamic language. It doesn't know at edit time, or even when the program is first run, what types of things various variables are. You can have a variable x that is assigned an integer at this point in the program and is assigned a string at some other point in the program. And Python is perfectly happy to do that because the variables in Python don't have types associated with them. They just have values. Python code can write other Python codes. You can actually have Python programs that rewrite portions of itself. So that makes Python really hard to compile because a lot of the information about the running program is not known until you actually run the program. It's very difficult to write a compiled or create an implementation of Python that's compiled. That's not to say that hasn't happened. Certainly there are Python compilers out there, but they start making restrictions on what you can and can't do. Like the Python compiler might say, once you assign a value to a variable, you can't change what type of thing that is. So if you assign the number 5 to the value x, the variable x, then you can't later on say, okay, the variable is now the word hello. Or it might say, you know, Python programs can't rewrite themselves. These are like kind of fringy things that you usually do anyway. So if you put those restrictions on the Python program, then you can compile it very nicely. Or maybe you could half compile it. You could compile it, tokenize it, do some optimizations, and then from there, run the interpreter, but now the interpreter can make some assumptions about how the program behaves. Another thing that's used is what are called just-in-time compilers, JITs, J-I-Ts, just-in-time compilers. And Java uses this in order to speed it up, and they're starting to research using JITs for Python code. But the idea there is that you run your Python code as normal, and then as the program is watching, as the program is running, there's a little piece of code that's kind of watching the program, just kind of keeping track of which parts of the program get used a lot and which ones don't. Parts of the programs that get used a lot would be things inside of loops where the loop has to run frequently, or functions that are called frequently. And so after a while, it'll say, hey, this function is being called quite a bit, and the function doesn't do anything too outrageous. So why don't we very quickly take that Python code and compile it into machine code? So next time we call that function, it just runs the precompiled program, the precompiled code directly. And so it's called a just-in-time compiler because at the moment it's needed, it does that compilation. So current Java runtime environments do the same thing. They watch your code, and then if it sees that part of your code gets called frequently, it will very quickly compile that down to the native machine code for that processor, and then that program will run faster as a result. And it's kind of interesting, if you can profile these programs, you can see they start out running slower and they get faster and faster the longer the program runs, because more and more of the code has been compiled into the native code, native machine code. And that's what makes, for the most part, Java programs almost as fast as C and C++ programs because of this just-in-time compiler. And the other cool thing about the just-in-time compiler is it has kind of like more information about your program as it's running than the compiler would have before your program runs. So it's able to do things like optimize loops and optimize functions based upon, and maybe even combine functions together if it sees that, well, function A always calls function B, so why don't we just blend the two of them together so they'll run faster. Are the binaries produced by the Python compiler be very large? Actually, I don't know the answer to that. I mean, it still has to go with a runtime environment, right? You can't get away with that. So you could do it the way Java does it, which is the compiled binaries themselves are fairly small, but it comes with a runtime environment that's fairly large. How to run C programs online? You know what? There's C to JavaScript compilers. There's one, I think it's called Emscriptum, E-M-S-C-R-I-P-T, Emscript, I think that's what it's called. And it will take a standard C program and turn it into JavaScript code. And then you can run that JavaScript code on the browser. That's how things like these, did I show you in this class, like you can run these emulators for video games? That's how those things work. The emulators were originally written in C to run on a computer, but then someone ran Emscriptum on them, and now those C code runs on in a browser. So that's kind of cool. I haven't played around with that very much, but that's kind of a cool idea to take a standard C program and turn it into JavaScript. What else we got here? I think I've caught up on most of the questions. Are device drivers written in C? I would say yes. They're typically written in C or C++. Possibly because they need to be standalone, so they probably shouldn't have a giant runtime library associated with them. They need to be fast, and they probably need to be able to work with the hardware as directly as possible. So they need to be able to pull data off of a system bus, do something with the bits, analyze data packets, and then push them out the other end. So that all has to be done pretty quickly. The things like the operating system kernels themselves are most likely written in C or C++, and so it also helps to have device drivers that are written in the same language so that the parts of the kernel can easily call functions written in the same language. If they're written in a different language, then you probably need to do some kind of translation to translate the way C functions are called versus, let's say, the way Java functions are called. Right? They push parameters on the stack a little bit differently. They push different addresses on the stack. And so there usually has to be some kind of translation that happens. What does the arrow do in C code? You're talking about this one here, right? So you remember if you have like an integer pointer, or let's say struct, I don't know, struct GPS. And then you have a struct GPS pointer. Let's call it location. Then if you wanted to get access to the latitude field of this location, you would do it one of two ways. You would say location pointer latitude, or you could do dereference the location and then a dot lat. And these two are equivalent to each other. So you can dereference the pointer and then use the dot to get access to the fields. But doing this is so common in C that there's a different notation for doing it. And these two, like I said, are equivalent to each other. One is not faster or slower than the other. In fact, when you write the arrow, it probably will turn it into this bottom one here. John says, kind of behind using pointers, wish I had to work with them more often. You know, pointers are not necessarily something you will get the first time you use them, or even the first semester you use them. It probably will take repeated exposure to them. And back when I was in university, I learned C as the third, by the end of the first year, by the end of my freshman first year of college, we were starting to learn C. And then that was pretty much the language we used from that point forward for the rest of our college courses, our university courses. So I got lots of opportunities to use C over and over and over again for the next 3 or 4 years. These days, you know, you learn C not as a mainstream language, but kind of as a, oh, by the way, it would be a good idea to learn this, but most of our development is done in using Java or Python, where pointers are really hidden from you. But in Java, if I was to say string x equals hello, and then I go x.length, I'm really doing the same thing. I'm accessing the length field inside of this string object. But behind the scenes, x is a pointer. It's not the string itself. So the dot in Java is pretty much equivalent to the arrow in C. Are there triple pointers in C? Sure. You could do that. It gets a little unwieldy. But sure, you could have pointers to pointers to pointers. Oh, you didn't see what I was doing on the screen here. If I have this string x and I assign hello to it, then x.length is just accessing the field within that object. But in Java, objects are just pointers to structures. And so the dot in Java is equivalent to the arrow in C. You think pointers are fascinating. It'd be nice to be more adept at using them. Already can see how useful they can be. Yeah, I mean, on the other hand, lots of languages have abstracted away the idea behind pointers, and so it's less. I mean, you're still using them. You're still using them. It's just that the language now kind of hides the fact that you're using them. Again, like in Java, if I was to say string y equals x, then what I'm really doing is I'm saying take the address contained in x and store it into the address for y, so that y and x aren't copies of the same string, they just point to the same string in memory. So the string hello is only stored once, and then y and x are just the addresses of where that string is stored in memory. Same thing happens for any other object type in Java. When you say this object is equal to that other object, all you're doing is copying the address. You're not copying the contents of the object. Is it possible to build a website in Excel and use Visual Basic? That's out of my area. Microsoft would probably say, sure, you could build a project or a website in Excel and then use Visual Basic somehow to display it on the screen, but that's not something I personally do myself. So I don't have a good answer for you. Anything else? So for those of you who are watching this in my C class, I'm also going to post the video that I recorded yesterday. And yesterday we had a guest on. We had a former Sierra College student who's now graduating from Sac State. And he was kind enough to come on the Zoom and talk for about an hour about what it's like to be a student at Sac State who transferred from Sierra College. He talks about what are the courses that you need to take, what are the first courses that you'll take when you transfer over, and then give you some recommendations about other courses to take. What's it like? What's the workload difference between upper division work at a university and the lower division work we did here at the community college? Where are some of the overlaps? You learn some of the in a class like this, the C programming class, and in discrete structures, and in the Java class, and the database class, and where do those course contents overlap with the courses they offer at Sacramento State? So I'll post a link to that video, and it will be great to watch if you are planning on transferring to a university, particularly Sacramento State, in the near future. Anything else? Chris, good?
I'm good.
Right.
Thank you very much for this course. This has been a lot of fun and very educational.
Are you going on? Is this the end of the road for you?
Well, I would like to go on and get a degree, but I'm not sure time-wise. I work full-time and have kids, and we have a lot going on. So
yeah. It's more difficult.
Yeah, it makes it more difficult time-wise. So I'm continuing to take classes that help build or expand my skill set. But whether I go on and do the degree, I don't know yet. I'd like to.
So have you been taking these courses just as a kind of general interest, or are you planning on kind of switching careers?
Well, I do. I program full time. I'm a software developer, but my educational background and professional experience is in a different field. It's actually in architecture. And so a few years ago, 5 or 6 years ago, I switched careers and started doing software development. And but I don't have that. Haven't had that college formal study background.
I see.
So I wanted to strengthen my understanding in mathematics, algorithms, a more computer science way of thinking about things. And so these classes have been helping a lot.
Good. Well, best of luck to you.
Yeah, well, thank you.
Thinking about taking my other class?
That was the discrete structures. I took that last year from you.
Oh, okay.
Yeah. I think it was first, it must have been fall last year.
Got it.
Yeah.
All right. Well,
I wish you taught other classes. I like your teaching style and the depth of information you go into.
well, before the pandemic hit, I usually also taught the second semester Java class.
Okay.
But once we went, we were thrown into this all of a sudden, everyone decided to kind of consolidate and not have too many classes to teach. So we all taught basically like 2 classes, and we just divvied up the work amongst us. And so here we are. So maybe at some point it'll go back to that. But we all kind of found our area of interest and area of expertise. I do have an interest in putting together a introduction to quantum computing course. And the tricky part there is when you want to propose a new course at Sierra College, you can't just create a new course. You have to show that there is some need for it. So you either have to do a little bit of research to find out, are employers looking for somebody with these skills? And lacking that, you can fall back on, is there some other university or college within the state of California that's also offering this same course? And if there is, that's easy. You can just say, I'm offering the same course that, I don't know, Palomar College is also offering. They're offering Introduction to Quantum Computing. We're going to do the same thing. Right? That's a no-brainer. Problem is that quantum computing is usually an upper division or a graduate level course at this time in the year 2022. And it's very difficult to find someone offering it at the lower division. But I think that this is something that people ought to be exposed to during their first couple of years, if only just to get the very, very basics of it. And so it's going to be a little bit tricky to make the case that we ought to be the first college offering a course like that. Because obviously there's no employers who are looking for someone with quantum computing experience, because it doesn't exist yet. But someone has to be first. And that's kind of a chicken and egg problem. Like, how can you be the first university to offer a lower division course? I mean, if you're not the first, it's easy. You just copy what someone else did. But if you're the first, it's harder. So that's what I got to figure out. So I want to do something like that. I also want to look into another programming language called Rust. It has nothing to do with the video game Rust. It's a programming language that is trying to kind of position itself as a replacement for C. C has done very well as an embedded systems and a systems programming language for decades, but it has problems that have been exposed over the years, mostly having to do with its standard library. It's very easy in a C program to do things like run off the ends of arrays. It's very easy to not set aside enough memory in a string to hold users' input. It's very easy to lose track of pointers and have memory leaks. Those were all probably assets back when C was first created, because you didn't waste time checking arrays bounds, and you didn't waste time or memory keeping track of memory allocations and deallocating when they were no longer being used. But these days, those are probably considered to be faults of a language. And so Rust is positioning itself as the speed of C and the flexibility of C, but addressing a lot of these shortcomings. You can do things like do arrays checking in Rust, and then when you're ready, when you're pretty sure that the arrays are not being overrun, you can turn that off and get better speed out of it by not doing the bounds checking every time you access an array. Memory management is more done for you than it is in C. Again, I don't know a whole lot about Rust, but I know that this is what it's being positioned as, and it would be something to learn. And if I can learn enough about Rust, then I would also like to offer a course in Rust programming so that somebody who wants to pick up Rust as an embedded systems language or a systems programming language can do so. So more and more, we're starting to see applications come out that originally would have been written in C, that have been ported over to Rust, or were just developed in Rust to begin with, rather than C or C++. So I'd like to learn a little bit about Rust and be able to program in that. Maybe that's something to do over the summer, is fire up that project Euler and just start writing programs in Rust. Just, again, for the practice of developing programs from scratch, solving problems in a Rust way, and then just, seeing how I use sites like that to just learn a new language. It's a great way to do it. Rust programmers call themselves Rustaceans, kind of like crustaceans, right? But Rustaceans. Does Rust have a book for their language? There probably are books, but most of it's done online. Rust language. And one of the nice things about Rust also is, of course, it's compiled and it can be run on your computer, but the compiler is also available as a JavaScript plugin, and so you can compile and run Rust programs entirely in your browser, I think. Right? What am I looking for? I'm looking for the place where you can Is it this one? Oh, here we go. Are you? No, we're not looking at what I'm looking at. Sorry. I'm on this website. rust-lang.org. And then you can click on Learn. And then check out Rust by example. And so here's what a hello world looks like in Rust. Function, main, you got your friendly curly braces and semicolons and parentheses. So it looks a lot like C. And then you click on Run, and there's the output right there. And you can also compile it yourself and then run it right on the command line. And then it says, add a new line so that it shows hello world and then I'm a Rustacean. So we will come up here and go print line exclamation. I don't know what the exclamation mark is for yet. There we go. So then we go on to the next one. Comments. Okay, comments. Standard comments. We got // we got /*. Documentation comments are turned into HTML as 3 slashes or 2 slashes with an exclamation mark. So we got format, print, print line, ePrint, ePrint line. And then this one deliberately has some syntax errors in it, so you have to go fix. the errors. This is kind of like what printf looks like in Rust. You've got these placeholders. And I think the nice thing about this is in printf, you have to know what the types are. You have to know that this is a float, and this is a decimal integer, and this is a string, and then put in the appropriate placeholder. In Rust, you just say, I want to put in the 0th placeholder, which is this one here, and then I want to put in placeholder number 1, and then it figures out what the type actually is. Oh, yeah, I think that's right. And then fix me, comment out this line. Okay. That worked. So I don't know enough about Rust to be able to develop any kind of opinion on whether it's, I would prefer it to C or C++. I do know that Rust comes with its own compilation manager called Cargo. So whereas in C you would typically use something like make or CMake, in Rust you use Cargo. And it handles compiling and working out all the dependencies for you. It's kind of like Ant for Java. One of the current problems with Rust is it uses a different runtime library than C does. The reason why the C executables are so small is because the runtime library is a separate file on the operating system. So when your program runs, it loads in your executable into memory, and then it links it to the runtime library. And then your executable in memory is larger because it has put those two pieces together. But in Rust, because it uses a different runtime library than the C programs do, it has to compile in its own runtime library, which means the executables for Rust are much larger, like several hundred kilobytes instead of just 1 or 2 kilobytes. And what that means is, of course, it uses more disk space per executable. And it also means that it means your executable is now intrinsically tied to the standard library that existed at the moment your program was compiled. So if a bug is found in the standard library, then you'll have to recompile your programs. If a bug is found in the standard C library, then all you have to do is install that updated library, rerun your program, and then it picks up the changes immediately. So that's kind of a downside for Rust, is currently the runtime libraries are not dynamically linked at runtime. They are statically linked at compile time. And I suppose maybe if Rust catches on, that would change as operating system vendors start distributing the runtime library by default, like they do with the C library, but that's currently not the case. So that's why they have to be compiled with the library linked in at compile time. So yeah, I want to learn Rust and see what advantages it has over C, what are some of the pros and cons of it, maybe do enough work in it that I can start kind of developing an opinion about which one I prefer. But right now I'm not there. But this website has about 24 or so tutorials for you to go through and learn all about the basics of Rust programming. And then someone pointed out that there are some books. So O'Reilly's got some book. No Starch Press has some books. Yeah. Books are starting to come out now. DLLs, is writing them much different from writing your average static library? Talking about specifically Windows DLLs or just dynamic libraries in general? If it's dynamic libraries in general, no, there's not that much different. There's a couple of flags you have to pass into the compiler, and then it will ensure that when it compiles the program, it does not use any absolute addresses, it uses relative addresses. So that when it gets linked into your program, it doesn't depend upon where in memory it gets linked in. But that's really pretty much the only difference. As far as I know. I haven't done much dynamic library writing myself. I just see the compile command go by when I compile programs that other people have written. I see, oh, it's just a command line flag being passed in. It ends up with a different extension. It's not .o, it ends up with either .so, stands for shared object, or it ends up with .dylib, dynamic library. But they're basically object files, but written in a way that they can be linked into other programs at runtime rather than at compile time, which means addresses need to be resolved later at runtime rather than resolved at compile time. Okay. Will my future lectures be on YouTube? Yep, I don't anticipate taking anything down, and I'll just continue streaming to YouTube next semester. All right. Well, again, it was really great having you as a student this semester, and I look forward to talking with all of you next week. I have some work to do this weekend to catch up on recording the assignments. I got a little behind in this class because I was working on keeping the other class up to date. There's 100 students in that one, so there's a little bit more work to do. But I'm going to try to catch up this weekend on the programs for this class. And so watch for the announcements, watch for the notifications that assignments have been complete or incomplete. And if they're incomplete, look for any notes about what you can do to fix them. And then also look for an announcement that I'll make when I have figured out what's going on with the time slot signups. I don't yet know what's going on there, but I hope that have that resolved in the next 24 hours or so. Next semester will be beginning in late August, and it will be the exact same class. Hopefully I'll have some new content. I don't know what yet, but I'm always learning new stuff, and so always changing up the course just a little bit every semester to introduce some new content, but for the most part it will be the same course. That's the life of a college professor. Just every 6 months you start all over again. It's kind of like being an actor in a play, except that the play doesn't last 2 hours, it lasts 3 months, 4 months, and then you just do it all over again. And hopefully every time you do it, it's a little bit better than the last time. Okay, well, if there's no more questions, then why don't we wrap it up here?
All right, well, thank you very much.
You're welcome.
Have a good weekend.
You too, and I'll see you next week.
All right.
All right, bye-bye.
Bye.
Record.
And then YouTube folks, same thing. It was really great this semester to see the YouTube stream really take off. Last semester I started doing it and I would have like 1 or 2 people, and then this time I've got about a dozen people watching, so that's really great, and hopefully maybe next semester we'll have even more. I'm hoping over the summer that I might do a few streams where I maybe show you some of the work. I talked about some of the projects I'm working on over the summer, so maybe I'll get a chance to stream some of those and kind of keep you up to date on the progress on those. Or maybe I'll do some of the programming on the old Apple computers and I'll show you what I'm doing there. But that's my hope. But they will be infrequent. I'm not sure when they'll be. let me know when I schedule a stream, like when I actually go through, in YouTube, you can pre-schedule your streams. You can say, I'm going to be doing one tomorrow at 9:30 in the morning. Do you get a notification when I do that? Or what happens? I don't know what it looks like on your end. Do you get a notification when I schedule the stream, or do you only get a notification when the stream is like imminent? Yes, the answer is yes. Yes, yes, you get a notification when I schedule it, or yes, you get a notification when it's getting close. Oh, you see them all posted at the same time usually. That's because at the beginning of the week, I go through and I schedule all the streams for that week. Because that's when I know what the content is going to be. So, oh, some of you are saying you do get the notification when the stream starts. And sometimes I forget to hit the button to make it start until just before I start. Usually I try to do it like 5 minutes before the stream starts, just so you'll have some notification, but sometimes I forget to do that. There's actually a fair amount for me to remember to do. I have to start up my Zoom going, and actually today I just realized I forgot to put my own face up on the Zoom recording. So you're just going to see an icon there. And then I have to remember on YouTube to start the stream and then click the button to go live and start the Zoom recordings. And sometimes I just forget. Okay, so you see the schedule on the main page, but the notification when the stream starts. Okay, that's good to know. So that means that if I know that I'm going to be doing a stream, let's say tomorrow or 2 days from now, you'll at least see it on your page that I've got something scheduled. Good to know. All right. Well, I think it's about time to wrap it up. So there will be no streams next week. I'm just meeting with my students. And the next time you'll see me will probably be sometime during the summer or in August. Well, I hope you all have a great summer. If you are a student, I hope you wish you well on your studies. And maybe you'll get a little bit of a little break this is our summer, but if you're in the Southern Hemisphere, this is your winter. But we're going to be taking the summer off, and then we'll be back in the fall. Thank you. Oh, thanks for the thanks. I'm glad, is it Burke? I'm glad that these classes really did help you. That's good to know. You're very welcome, everyone. Thank you for watching. It's been great getting to know some of you. It's been great seeing some of the same names pop up every day. That's when I know that I've got the streams going, because I start seeing the same names over again. It's really kind of comforting, actually. All right, take care, everyone. Hope you have a good summer or a good rest of the day, and I will see you soon. All right, bye-bye.